Hey everyone, and welcome back to That Engineering Girl. Today I wanted to go over the long overdue video on how I did my first PCB, how I went about even designing it, and my thoughts on PCB design. Is it something that I'll ever do again? We'll find out. And before we even get into the video, I'll address the elephant in the room. Yes, I'm wearing a brace. Yes, my wrist has been hurting for a year, and yes, I didn't get it checked out by the doctor until a year after, where I couldn't bear the pain anymore. And yes, please do not make the same naive decision as I did. That's all I'll say, because now I'm suffering and now I can't properly type and finals are coming up and I do not even know how I'm gonna write my upcoming quiz next week. But alas, that's not what this video is about. Let's get into it. Alright, so how did I start? Well, I started in the way you start anything, and that's by going to YouTube. And I didn't actually directly go to YouTube first. I actually went to the Easy ADA platform that I was going to be using to actually build and prototype the PCB and put together the schematics and all of that jazz. And so then I was actually referred to their tutorials on YouTube, and I watched their beginner tutorials that were about, I think in total of around 2 hours, and they were helpful from a high level. They definitely did not make me good enough to actually go about building a PCB on my own, like from scratch, having no questions, wasting no time, just going about my business. That was definitely not what those videos were for. They're more so to introduce me to the features and functionality and procedures of PCB design. So how do you actually go about starting? Where do you look for components in the library? What are the different libraries that are available? Which ones do they recommend using and which ones do they not recommend using, and for which reasons? And things along those lines, especially creating your own components with their own footprints. That was extremely useful. The fact that I knew that that feature existed, although I wasn't 100% on it and I couldn't actually use it from the get-go because of course I'm a beginner. Later on, when I needed to do that, I knew it existed. So these tutorials were super helpful in just getting myself familiar with the platform, the general procedures of PCB design, and the general steps from a very high level that I would have to follow in order to complete the PCB that I was designing. And of course, as always, I was still very confused, which is the way anything goes, right? When you're trying to learn something and you're pushing yourself out of your comfort zone and you're trying to learn something new. That's always what it will be. You'll always be confused until you actually start doing it and start answering the questions and asking questions, actually, because you don't even know what questions to ask. So just diving in and getting your feet wet, I think is the expression. That way you'll actually be able to make progress. So that's exactly what I did. Even though I was extremely confused, I just got on the platform of Easy EDA. And by the way, this isn't sponsored at all. This is just the platform that I used because it's supposedly easy, as the name suggests, and it was available online. So that was the perfect combination, because if I didn't have to download software, I don't want to. So anywho, that's what I ended up doing. I just signed up for an account and I logged in and started fiddling around with the different sections of the platform and just getting myself familiar with the different areas of the interface. Then I actually got started on the actual schematic. So this involved me thinking more along the lines of, okay, what's connected to what? What does this actually look like from a PCB perspective? So for example, there might be an alarm connected to a voltage divider or in series with one of the resistors of a voltage divider configuration, but that alarm might not actually be on the PCB itself physically. And that's actually one of the parts of our design. So that's an example from the way we were creating our design and the way our PCB needed to accommodate that section of our design. So that alarm was off board and we just needed to connect it to the PCB through screw terminals. So thinking about the actual real life connections is a lot of where my time was spent initially with this schematic, is how are things actually in real life going to be tangibly connected? That's what I needed to figure out first. So this is where I actually learned to create a custom footprint for myself. Now, this wasn't actually a very complicated custom footprint because it was simply literally just using up area. So we were buying a buck converter and it was coming on its own custom PCB, which we were then going to mount onto the PCB that we were creating. So really its footprint that I was creating was just literally a rectangle and then a schematic symbol that I would be using and then just marking its connections as void, essentially as null, so it's not actually connected to anything. And that's where I got to use the whole feature of custom footprints, and it was super fun and exciting getting to learn that. One of the big problems that I ran into, and this is something that I previously referred to very briefly, is the connection. So how are things actually connected with each other? Through this entire process, I found out that the amount of times that you have to change your idea on the type of connections to use varies a lot, because initially I was thinking we would use headers to connect stuff, but then we changed to screw terminals because I was talking with the tech lead and he said to me, hey Ruha, we're putting a lot of power through this, we have to be able to handle that, and headers can absolutely not handle that, so we're gonna have to use screw terminals. So then I had to update all of the connections to include screw terminals in the place of headers, and then eventually we actually switched to power poles for the battery itself. So initially the battery was being connected through screw terminals as well, but then later on the team members that was actually working with the hardware suggested we use power poles instead, because that's what he's worked with and he already had some lying around, and it seemed the most easy to just use those instead rather than having to buy and use screw terminals. So then I switched to using power poles on the schematic for the battery connection itself. At this point, I had to actually connect all of the power stuff, which was the main point of the PCB, to the ESC, so the electronic speed controller that we were using to actually control the motor of the car. That was actually also being added to the PCB itself. So we had two separate parts, but they were both being mounted onto the same PCB. So then I had to grab the schematic from our tech lead who was working on the ESC and integrate it and accommodate it into the schematic that I was already working with. So that was another step that I had to go through. Now after finally having the actual schematic finished, I then moved on to actually creating the PCB. So the actual tangible board that I would be holding in my hand when I ordered it. So this required me to switch into the PCB interface. I don't actually remember exactly what it's called off of the top of my head, but essentially where you actually go about converting the schematic to the actual PCB that you'll be ordering. So then I had to go about doing that. So at this point I had to get super creative because there were no real guidelines as to how to do this except for the fact that, you know, just put things where they look nice and where you save as much area as you can. So condense everything as much as you can. So those were my two high-level goals when I was actually creating the PCB. With that, also make it look somewhat coherent where it makes sense where things are. For example, I'm not going to put a connector in the middle of the PCB board. Instead, I'm going to put most of the connectors, so anything that's connecting to the outside world, so anything that the PCB itself is connecting to that's not on the PCB itself, on the edges around on the PCB border, because that just makes it much easier to actually connect things. So once I'd finished this, which took me, mind you, a long time, because this is actually no trivial process. You actually have to be very cognizant of where you're putting things. And one of the steps that I overlooked here is trace widths. So I'll get to this in a second, but this caused me a little bit of problem later on, and I'll explain why. So this is something to keep in mind at this step. So next I actually made those traces. So traces are essentially connections between the different components on the PCB board. So anytime you see a node on a schematic, that's essentially just a trace on the actual PCB. Now, I will be forever grateful to the Easy EDA software for actually having things connected loosely in the interface. And what I mean by that is it shows you all the connections that need to be made, and then you solidify where they're actually going to be routed. So you actually do the routing, but it shows you the different connections you need to make sure that the schematic is transferred correctly and accurately to the actual PCB. So that was by far the most helpful thing I came across when designing this PCB. So at this point, I had actually finished the PCB itself, but as someone has said to me previously, that's the easy part. The hard part that requires most of your energy is the actual reviewing and the verification of what you've actually built, which I can attest to that that happened in this case. And what I mean by that is, by fiddling around, I actually came across this design rule check feature, which, mind you, you should absolutely definitely use and go over that. I stumbled upon it, and thankfully I did, because it was super useful in verifying that the actual PCB met our design constraints in terms of trace widths, in terms of, you know, how close can connections be to each other in order for signal integrity and those kind of things. So with that, initially the design rule check passed for me and I was super happy. However, when I connected with the tech lead to review the PCB, as the tech lead was already familiar with PCB design, and so he was kind of mentoring me on this entire process, and so when I connected with him to review the PCB, he actually mentioned that the trace widths need to be adjusted in terms of how much current and how much power they're actually carrying. And because we were actually designing a power supply, we needed to be careful about the trace widths. So he referred me to this online tool that calculated the minimum width of your trace depending on how much current it's carrying, and a bunch of different variables that were taken into account. And this was more so guess and check on our side, where we were estimating these variables that give us a good enough estimate or a good enough approximate of the minimum trace width that we need. So with that, I actually had to make a bunch of trace adjustments afterwards, because many of the traces that were actually carrying power did not meet this minimum requirement that we had to increase from the standard design check metrics that are initially used in EasyEDA, and I'm pretty sure any other PCB software, because these are just standard metrics that are used as defaults. So once I'd actually fixed the trace widths, confirmed with the tech lead that everything looked good, then I was finally able to actually order the PCB, and this was the most exciting thing. Now, there's a lot of options when you actually order the PCB, and the tech lead just advised me that, hey, don't worry about it, these are just default settings, and for our purposes it doesn't really matter what these are, so just leave them as they are. And I did go over a bit of what the actual settings were, just out of pure curiosity, but I didn't have to worry too much about that. And then once it was ordered, I sat back and sighed in happiness, because I had just designed a PCB. So with that, that's actually how I went about actually designing the PCB, but what are my thoughts on doing it? Well, I absolutely loved the process. I think I learned so much, and PCB design is a super important skill, in my opinion, for anyone doing anything really in the electrical / computer industry. Now, I may not be doing power, and I may be more interested in the computer / digital side of electrical engineering, but PCB design will always come up here or there or somewhere in the field that you're working. It is almost a given that you're gonna have to work with it. So being able to learn the skill was super important, and I also loved the fact that I got to connect a lot with the tech lead and bounce back questions between him and I in order to learn more and really accelerate my growth on the actual variables and things that go into actually designing a PCB, and how accurate do you actually need to be to design this. So for example, if you're gonna be using a resistor in your schematic and on your PCB, what exact footprint for that resistor do you use? Is any really good enough off of, you know, all of the footprints that are available to you, as was with us, because we just wanted any standard vanilla resistor. We honestly did not care that much about it. So being able to figure out these things was super beneficial, and I'm sure are going to help me in the future. With that, this experience was a huge plus, a huge positive, and I'm super glad that I got to go through it, and I'm confident that it's gonna help me out in the future. Alright, and that was my experience designing my first ever PCB. I hope you enjoyed watching my review, and I hope you were able to gain some sort of insight as to what it is like designing a PCB as a beginner. So with that, until next time.